Okay, factoring polynomials. We're going to use the factor theorem to determine factors of a polynomial. So the factor theorem, it is such that if we divide by an x minus a, the remainder is the function at the value of a. That remainder will be 0. So that means if I divide, say, I have x minus 1, and I divide by 1, my remainder will be 0, and then it is a factor. So I think it's best if we just use an example. And the best way to check these is that way that we liked or seem to get better, which is synthetic division. And remember, for synthetic division, it needs to be in the x minus a form. So my a, in this case, is 3. So I divide by 3. Remember, you have to use coefficients in standard form, so this does decrease perfectly. And then you bring down, multiply, add, multiply, add. So I get a remainder of 12. So the function evaluated at 3 is 12. So it does not give me a 0, so this would be no, it's not a factor. In this case, my a is -4. So I use -4 in my synthetic division. And I look, I have x to the 4th, x to the 3rd, no x squares. So 0, 2, 8. Carry, bring the first, multiply, add, multiply, add, multiply, add, multiply. And I see that the remainder is 0. So yes, x plus 4 would be a factor of that polynomial. So I'd like you to go ahead, pause the video, and try these. So in B, 3x minus 6, while it's the factor, I can factor out a 3, so I can use the 2, because I need to be in x minus a form. And then make sure I'm in standard form. So how can you use synthetic division to tell whether a given binomial is a factor of a polynomial? If p at a equals 0, or the remainder equals 0. Now another way of factoring is this thing called factoring by grouping. And what you do is you group, when you have a polynomial that's more than 3 terms, you can combine and factor them by grouping two binomials together. So when I look at the first set, the x to the 3rd plus 3x squared, I look for the GCF, so x squared, get x plus 3. I need the second pair to have that same factor of x plus 3. The only way I can do that is if I factor out a -4 Then I have the common factor of x plus 3. And I'm left with x squared minus 4. If that can be factored, then you need to continue factoring, and that is a difference of 2 squares, which factors into an x plus 2, x minus 2. Okay, so again, factor by grouping. I recommend grouping the first two, then the last two, and see if that works. In most cases, it will. And you have a difference of 2 squares. Oops. 4. A sum of 2 squares does not factor. And that's the end of day 1.